Hello and welcome to the first Python coding challenge. Today I will give you the solution to last week's challenge. So if you haven't seen that video, make sure to check it out first by clicking on the link in the top right hand corner of your screen. And then, once you've watched it, return to this video and see how you did. For those of you who have already given it a go, here's my solution. Bear in mind that this is not the only solution and that yours could be different. Nevertheless, here we go. First, let's write out our Sudoku puzzle. As you can see, I've already done it, and I've used a list of lists. This type of variable is called a nested list. We will cover it in an upcoming episode of my Python tutorial series, so make sure to subscribe to the channel and turn on notifications so you don't miss it when it comes. As you can also see, in the place of blank cells, I've used the number 0. Now, in order to write our Python solver, we need to first write a function that will calculate whether or not a number can be placed in a cell. In other words, it uses the 3 hints I gave you last time, which is to check that the same number is not present in the same line, column, or box. So let's write a custom function which we can call validate. And it will take 3 inputs. The y, which indicates the row that we are looking at, x, which indicates the column we're looking at, and n, which is the number that we want to place in the given cell. First, we have to check that there are no items that are the same as the number we want to insert in the same line, in the same row. So we can do that by iterating through all the indices in that row and checking whether the numbers match. We can do this by saying for I in range 9, because we know that there will be 9 elements in each row, so the indices will go from 0 to 8. And we can say if puzzle yi, so this will identify the yth row and the ith element in that row. And we can say if puzzle yi is equal to n, then return false. This means that if any number in the same row as the cell we're looking at is equal to the number we want to insert, the function validate will return false. It will say, no, we can't do that. Now that we've done all the numbers in the same row, we have to do all the numbers in the same column. We can do this in exactly the same way as we've just done, only that we iterate over the elements in the same column rather than those in the same row. So we can write for I in range 9, and then we say if puzzle I x, so this will identify all the elements in the same column, and we can say if puzzle ix is equal to n, then return false. So this will check all the numbers in the same column, and if any of them are the same as the number we want to insert, then it will return false. Finally, we have to check all the numbers that are in the same box. To do that, we first have to identify the indices of the elements in that box. So first, we can find the index of the element in the top left-hand corner of the box by doing ybox is equals to y integer division 3 times 3. Sorry, this should be outside the parentheses. So what does this do? This will find the largest multiple of 3 that is smaller or equal to the index of the cell we're looking at. In other words, it'll find the y coordinate of the cell in the top left-hand corner of the box containing the cell we're looking at. We can do the same thing also for the x coordinate and call it xbox is equal to x integer division 3 times 3. Now that we have the coordinates of the index in the top left-hand corner of the box, it's quite easy to iterate over the whole box by doing a nested for loop. Now, we haven't done nested for loops yet, but make sure to subscribe because I will be covering these shortly in an upcoming tutorial. So to do these, we just write for I in range 3, because remember that the box is 3 elements wide, and then a second loop to iterate over the columns, so for j in range 3. So what this does is it checks all the numbers inside the box containing the cell we're currently evaluating. So to get the number in each of the cells in the box, we just say if puzzle, and in this case we use ybox plus I for the y coordinate and xbox plus j for the x coordinate. And again, like before, we say if this is equal to n, so if any of the elements in that box are equal to the number we're considering, then we return false. Now, if none of the considerations we've listed above are satisfied, that means that the number we are considering can indeed be placed where we want it, and therefore we can return true. Now, we've written our function to validate whether a number can be placed in a given box. But now we need to write the actual solver to iterate through all the cells in the entire puzzle and come to a conclusion as to what the correct number is. We can do that by writing a second function which we will call solver. And what this will do is it will iterate through all the cells in the puzzle. So we need to again do a nested for loop, where in this case we iterate over 9 elements. So we say for y in range 9, and then for x in range 9. So we are iterating over all the rows and all the columns in range 9, so basically in the puzzle. And we say if puzzle y x is equal to 0, so if the cell is empty, now we have to check which of the numbers from 1 to 9 fit in this cell. To do so, we can iterate through all the numbers from 1 to 9 by doing for n in range 1 to 10. Now, if you don't know why I've written range 1 to 10, make sure to check my tutorial on the range function by clicking in the link in the top right-hand corner of your screen. Now, as we iterate through each of the numbers from 1 to 9, we have to check whether that number can indeed be placed in the cell that we are analyzing. How do we do that? Well, we've written a function for that. It's called validate. So we say if validate of what? Well, we need the x and y coordinates and the number. So we say y, x, and then n, which is our number. And if we say if it is equal to true, so the number can be placed in that cell, and we can do that by writing puzzle y, x equals n. Now here comes the interesting part. We can call the function again inside itself, writing solver open and close brackets, and this is called recursion. What this allows us to do is that while the function keeps getting the numbers right, so it keeps finding values to add to the various cells in the puzzle, it will carry on calling itself to move on to the next cell. Now we will look at recursion in more depth in one of the upcoming tutorials on this channel, so make sure to subscribe so you don't miss out on that. Now you might be asking yourself, what if the function doesn't find a value to put in the cell? So none of the values it looks for from 1 to 9 can fit in the cell. Well, in order to tackle this possibility, all we do is set the relevant cell, so puzzle y x, to 0. this will allow it to backtrack. And then outside of the for loop, we just put an empty return. This allows the function to continue assigning values to cells in order until it reaches a dead end. If it does reach a dead end, then it will backtrack by one cell at a time until it finds a new possibility. As I'm sure you can see, this loop and recursion combined will keep on going until all the cells have been filled. Once this happens, the if puzzle yx equals 0 statement on line 36 will actually never be triggered, and therefore it will interrupt the recursion and it will allow the function to end. However, although this is sufficient to complete the puzzle and successfully solve it, we obviously want to display the result in order to check that we have the right answer. Well, we can do that very simply by putting a for loop at the end of the solver function, which iterates through each row of the puzzle and prints it so that we can view it. So we can say for row in puzzle, we say print row. Finally, in order to make it so that the solver function is called automatically every time we run the code, we can simply call it at the end of our script by writing solver open and close brackets. That is all you need to write a Python solver for a Sudoku puzzle. So now, to check if it works, let's run our code by clicking on the F5 key. Now here we can see the result. If you compare it with the solution to the puzzle, you will see that it is identical. This means that our code has worked correctly. I hope you enjoyed this fun coding challenge, and I look forward to seeing you in the next one. In the meantime, make sure to check my tutorial videos, and you can access these by clicking on the banner in the top right hand corner of your screen or through the link in the video description. Also, make sure to subscribe to the channel so you don't miss any upcoming videos. See you next time!